All right, so in this question, we want to complete the ANOVA summary table. So as you can see here, they give you some of the information and they're asking you for the other part. All right. Okay, so the book is full with all the relationship between the sum squares, degree of freedom, and the mean squares. How do you find the F? All right. So in the beginning, they explain to you how to find each one of them separately. Thereafter, they give you the summary table, which is this one, and that's all what you need. So I just copied the output table for one-way ANOVA, and I'm going to fill it up, and then I'm going to apply the formulas described here. All right, so let's put the first one here. Let's start with degree of freedom. So degree of freedom right here, so that's going to be 2 and 46. All right, so the total here, so if you can see that if I add this degree of freedom, the C minus 1 and N minus C, my result would be this one. All right, so you just have to add them up and answer this one. And that's basically most of them like this. If I add here, I will get this. All right, so that's what does mean the total. All right, so in there I just type in equal sign, sum, open the parentheses, and highlight the two of them and enter. All right, so now I'm going to do almost the same thing for the sum of squares, which is this column. So the sum of these two numbers, it should give me the total. And you can confirm it here. The numbers should be the same. Yeah, probably I made a mistake here somewhere. So typo. So only actually 4 and I'm missing a 7. Okay, so that's a confirmation. Now going back to the table, I'm looking for the mean square. So there are two mean squares. One is the mean square among groups, all right, that's the first one, and the other one within groups, all right. So for the among groups, it's telling you just to divide the sum square, this is sum square, divided by C minus 1, that's degree of freedom, all right. So if I do division sum square divided by degree of freedom, I will get the mean square. So that's all what you need to do. Click on the mean square, equal sign. You're gonna select the sum square, divide right now by the degree of freedom. So select degree of freedom and enter. And I do the same thing for the next one. You're gonna be equal sign, select the sum square divided by the corresponding degree of freedom, and you get that number. All right, now moving on to the F stat, and the F stat is nothing else than these two values, the mean square among groups divided by mean square within groups. All right, so again, I'm gonna use Excel to do this. So equal sign, and then I'm gonna select the mean square among groups, which is the top one, divide by select the mean square within groups, which is the bottom one, and enter. Okay, all set. So now it's time to put all the data, copy and paste them, and round to 2 decimal places. Okay, let's check it. Great. All right, so the null hypothesis is always the same. So since we have degree of freedom here is 2, all right, so it means that C minus 1, that's the number of columns minus 1. So if C minus 1 is 2, C minus 1 is 2, so C would be a 3. So we are supposed to have mu1, mu2, and mu3 only. So the null hypothesis would be this one. And the H1, again, not all of them are equal. Okay, so that's gonna be the best choice it should be, I think, C. All right, now we are looking for the p-value. So the p-value, how do you get it? There is a function in Excel. If you have the f-value and degree of freedoms, it will give you the p-value, and that function is equal sign f distribution. All right, that's one. So be careful, once you put the f, you have f dot distribution, you are not selecting that one, right? So it has no dot in between, so don't make that mistake. So just f distribution as one word, FDIST. All right, and then I'm gonna input the x, which is the f value, comma, and then the degree of freedom 1, which is 2, comma, and degree of freedom 2, which is 46 in this case. Close the parentheses, enter. That's your, should be your p-value. All right, you copy it, you paste it, and round to 3 decimals. Okay, good. Now, comparing the p-value with the alpha value, so the alpha value is right here, is 0.05. So obviously the p-value is greater. So once the p-value is greater, we do not reject. So we have insufficient evidence. So if we did not reject right now, what the meaning of this? It means that we're gonna go with the null hypothesis. So this one would be true and this one would be wrong. H1, it would be wrong. So what does mean? H0 is true. So we are going with the assumption that mu1 equals to mu2 equals to mu3. So now for C, is asking you whether it's appropriate to use the 2K Kramer procedure or not, and no, we don't need it because we don't have enough proofs that this one is different. So when you use the 2K procedure, is only whenever you want to determine which ones of these combinations are different from each other. It means mu1 different than mu2, mu1 different than mu3, and so forth, right? Okay, and for this case, whenever we agree with H0, we don't need to do this procedure at all. All right, so we're gonna go with D because there is no significant difference among the groups. The 2K procedure is not appropriate, and I think that's all. Okay, done.